I am Dr. Barbara Parolini, and I will talk to you about the beauty and usefulness of imaging with intraoperative OCT. We will focus on perfection. I will show you when OCT guided me and I followed. These are the topics we will touch: peeling, high myopia, subretinal surgery, retinal detachment, and situation with no preoperative view. Let's start by saying when OCT is a guidance in peeling membranes. Why peeling need OCT guidance at all? Well, the retina is transparent and the membranes are transparent too, so how to distinguish one from the other? We can easily distinguish the retina from the choroid because the choroid is colored, but membranes are transparent, and here I am finding the plane of separation, but not all the cases are so straightforward as this one. And certainly staining is one solution, and here the Proveo 8 microscope is showing a separation of the membrane, which is stained with blue, and the view is marvelous, and I can easily see every step that I am doing, but this is not a solution in every case. For instance, how to see when there is no contrast, on how to verify the position of an ILM flap under air, how to verify the reaction of the retina in difficult situation at risk of iatrogenic lesion. Look at this case. On the left, the microscope view shows a very little because there is no contrast due to atrophy and microretinal hemorrhage, microhemorrhage. So on the right, we see that the intraoperative OCT can tell us easily where there is the ILM flap and where there is a hole. So here under air, at the very end of the case, I am staining again, but reflexes and atrophy prevent the good view. And so if you find, like in this moment, with all the reflexes, you don't see exactly what you're doing through the microscope, while the intraoperative OCT tells you what to do because the ILM flap is in the hole. And this seems a similar situation of peeling, but indeed they are very different. The one on the right is in this type of fundus, while the one on the left is in this type of fundus. They are very different cases. This is a 50-year-old male with a severe myopia and extreme atrophy. He was operated by me for retinal detachment, and 1 year later he developed this bad gliosis. He was desperate. I've been waiting because I didn't want to operate, but then vision went down and down, and I had to remove that gliosis. So while I was peeling, I was asking myself, am I detaching the macula? Am I creating a hole? Am I peeling too much? Am I peeling at all? And looking through the microscope, I was not sure about the answers. I had many moments of uncertainties because I did not have all the information that I needed through the microscope. While through the intraoperative OCT, I had an immediate answer. I could see that in this moment I was just caressing the gliosis, but I was not efficient in removing it. While then I started to peel and I could remove the epiretinal proliferation, unfolding the retinal folds. And so I knew what I was doing, and I also knew that I was not inducing a macular hole. So this is new concept for intraoperative OCT. The microscope shows the movement, while the OCT shows the effect of the movement. It shows the shadow of forceps, the edge of peeled epiretinal membrane, the retinal folds which are unfolding. Again, you see on the left the forceps performing certain movement, while on the right, you don't see your hand, you don't see the instrument, you see the effect of your movement on the tissue. You see the epiretinal tissue, you see the folds of the retina which are unfolding. And this is the pre and post-op of that specific case. So what about high myopia surgery, and what role has the intraoperative OCT in this type of surgery? So this is a new staging system of myopic traction maculopathy that I recently published. And so the whole variety of MTM types are summarized in one single table that shows the evolution from inner schisis to macular detachment from stage 1 to 3 to 4, and on the horizontal evolution you see in the columns normal fovea evolution to lamellar hole to full thickness macular hole. MTM can evolve from top to bottom, from left to right, and in oblique. And focus is useful both in vitrectomy and in macular buckle in high myopia. In vitrectomy, again, to see when there is no contrast. Look the comparison between left and right through the microscope. We barely see where the macular hole is, while on the right we know exactly what we are doing. The ILM, which is large enough and is exactly on the hole. And this is another example. If you compare the two images, you see that on the right you have a great help. With buckle, OCT is useful to see the location of the buckle and the pushing effect, the buckling effect. You also see the hole over the buckle. In this case, look at the intraoperative OCT view. It is very informative and you know exactly what you are doing while inserting the macular buckle. And again, here you see that the hole is closed and is on top of the macular buckle, while on the left you could have many uncertainties on what you're looking, especially through air. This is an extreme case. I am implanting a macular buckle only with the guidance of intraoperative OCT without endoillumination at all. This is only buckle with no vitrectomy. So you see my coworker pointing and the location of the buckle, which is exactly under the fovea, and you see the images live through the intraoperative OCT. So what about cases without preoperative view, cases where media opacity prevents performing the OCT preoperatively? So you go to surgery, but you don't know the status of the fovea. Well, you remove with surgery the opacity, in this case dense vitreous hemorrhage. So you can perform the OCT during surgery and you know whether you have to perform maneuvers on the fovea or not, like in this case. What about retinal detachment surgery? Well, besides looking if there is PFCL left under the fovea, you can decide whether to peel or not to peel the ILM. In this case, the thickness of the fovea was so little that I decided not to touch the ILM in order to prevent a iatrogenic macular hole. While in a case like this, the fovea looked thick enough, I could see folds, radial folds, so I decided to move on and peel the ILM. And on the right, I see the effect of my movement, but surprisingly enough, you see that the folds are still there after the peeling. Why? Look at through the microscope. Well, the OCT could tell me that there were microfolds on the choroid, but not in the retina. So my case was done. It was very informative. And you can also differentiate schisis and detachment. Look at this difficult case of retinal detachment associated with the X-linked retinoschisis. The first surgery was vitrectomy, buccal, removal of the inner layer of the retina, and siliconoid. And this is the intraoperative view of the second surgery for a relapse of detachment. There are many uncertain findings. I was wondering whether A was a hole, B was PVR or retinal folds or subretinal strands, C subretinal PFCL bubbles. The focus was a guidance to understand that actually A, yes, was a hole closest to a cyst. The B were areas of inner schisis and remnants of the inner retinal layer that I had trimmed in the previous surgery, and C were areas of schisis and not PFCL bubbles, so I did not have to go under and remove them. What about PVR? Can the OCT be a guidance here too? So this is a very bad case of PVR, but I think that this is worse. This patient comes for second opinions, but he already had 5 surgeries for retinal detachment. And I could detect a subtle retinal detachment in the inferior quadrants, but this patient is worse than the full PVR because he has higher expectation and he's tired of surgery. You cannot make mistakes. So I think OCT can help locating immature PVR, and also it helps in the judgment of residual traction. This is a pathognomonic sign of intraoperative intraretinal PVR. This is another example. If you go there, you know that you have to peel. And in fact, you see here that specific spot. I am removing, first I am searching for immature PVR, and with the scraper and the forceps, I am indeed removing some epiretinal tissues so the retina can relax and open. But you can also judge residual traction. I think this is one of the greatest challenges in VR surgery, how to judge residual traction. Can the intraoperative OCT finally be a traction meter or a traction detector? In cases like this, you can wonder, should the retinotomy be lifted again? Should the membrane by the retinotomy be peeled or left over there? Is there residual traction? It's not easy to judge. So look at there. The intraoperative OCT shows that the edges of the retinotomy are contracted and there are epiretinal membranes. So you move on, peel the membrane, elevate the retinotomy, and then reattach the retina. And then if you compare prior and after your maneuver, you see the difference. So after your maneuver, the edges are more relaxed and there is no residual traction. Like here, the edges are now relaxed and there are no epiretinal tissues membrane left to be removed. So the case is finished. And this is the post-op view. So in summary, I think that the advantages of the intraoperative OCT are confirmation of what we see with the microscope and ability to see what we do not see with the microscope. And the surgeon gain precision, speed, knowledge, research ability, and training efficacy. So one step closer to perfection, because to be able to see is to be able to do. Thank you.